powers an 8-inch ice auger to create a 10-foot vertical hole through the ice into the sea below. A modem is deployed and the GPS location is recorded. A networked radio system can activate and monitor any one of the 6 modems. After a runway check, the Buffalo aircraft touches down in half the 3,000-foot ice runway. The rear load hatch of the DHC-5 Buffalo opens, containing one entire AUV, boxed in sections, with consoles and recharging equipment. The modular design of the AUV allows for many shipment configurations. Sections are transferred from the runway to the camp in order of assembly. Sections are loaded on the track and wheeled into the AUV tent. The adjustable track system allows for free-rolling sections, a flexibility required to install components, make all necessary connections, and properly align sections. Connections are made between the main computer and inertial navigation system. One of the 2 battery trays is loaded. These dry components are housed in the watertight sections of the Explorer. When the control surfaces and nose cone are installed, all sections are sealed together and secured. An assembled Explorer rolls into the deployment tent, stopping under the gantry. The AUV team secures the Explorer to the lifts, removes the section dollies, and deploys the vehicle. The Explorer is lowered 30 meters into a dark Arctic Ocean. With lines released, the prop begins to turn and Explorer powers off out of sight, beginning its first mission. Through the modem field, the short-range localization system utilizes acoustic packet travel times to determine the vehicle's location and monitor its position during the lengthy spiral descent to the deep ocean bottom. Explorer's inertial navigation system begins to gather and process positioning and navigational information with a fixed starting position and a pre-programmed mission journey. The Doppler velocity log begins bouncing sound pulses off the seafloor. The shift in frequency of the return sound determines the AUV's velocity. Information gathered from the Doppler log, depth sensor, and other onboard sensors is fed into the inertial navigation system, which in turn makes adjustments as needed to guide the AUV to its projected target. Explorer autonomously detects obstacles and avoids them as it makes its way through Wilkins Strait between Borden and Brock Islands, out into the Arctic Ocean. 9 hours into an estimated 60-hour journey, the main and remote camps receive information that the AUV has successfully passed a checkpoint and is making its way to the drifting remote camp. Drifting approximately 2 to 5 kilometers per day, the remote camp requires a long-range navigation system to recover the AUV. The long-range acoustic beacon consists of an omnidirectional projector suspended in the water emitting a continuous tone. A 7-element hydrophone array built into the nose cone of the AUV can hear this tone at distances of up to 100 kilometers and determines the acoustic arrival angle of the beacon signal. The AUV then homes in on the projector. Once at the correct location, the vehicle maintains a holding pattern, triggering the variable ballast system. A pump draws oil from a rigid pressure sphere to inflate a collapsible oil bladder. The buoyancy increases as the bladder inflates, displacing water inside the free-flooding hull section until the vehicle parks itself under the ice. An ROV, a small remotely operated vehicle, is deployed to scan the ice under the camp, and once Explorer is located, recovery lines are attached to the AUV and the vehicle is returned to just under the ice hole, winched up into the catchy device and secured. In what is considered a groundbreaking initiative, Explorer receives an underwater while significant stored data is downloaded from its computer. Once fully charged, a new mission is programmed and Explorer is deployed from the remote camp. After a long spiral descent, the AUV maintains a holding pattern near the bottom. It is given the go command along with a sequence of prompts to ensure the sounder is operating and collecting data. With two-way communications, the AUV team is able to monitor the telemetry which indicates the vehicle is on a near-perfect heading and is safely proceeding on its mission. Explorer is now gathering data beyond Canada's 200 nautical mile coastline. The sounder collects bathymetric data in the uncharted area known as Severus Spur. 2.5 days after deployment, with the mission completed, Explorer homes in on the remote camp's beacon and finds its way to rest under the ice, less than 30 meters from the ice hole. Bathymetry is downloaded, batteries are charged, and Explorer descends one last time for the journey to the main camp.
By the end of the operation, the AUV, which is now officially christened Euphoria, successfully collected over 1,000 kilometers of bathymetric data in a continuous 10-day mission. It successfully homed to the remote ice camp from a distance of over 50 kilometers during the transit out, and again at the end of the survey mission. Euphoria also traveled to water depths of greater than 3 kilometers during these missions. Individually, these accomplishments are remarkable. Collectively, they represent a world record for under-ice operations in the Arctic and have provided critical data for Canada's UNCLOS submission.